Hey guys, so today I want to talk about AI again, and this time I'm going to be talking about retrieval augmented generation. In a previous video, I talked about vector searches, and this kind of builds on that same concept, but it adds another element to it. So I'm going to talk about what retrieval augmented generation is, as well as relate it to vector searches and how these two kind of come together to create a robust and enriching application experience that can query data and also use generative AI at the same time. So first I want to walk through kind of the architecture of how this works. Then we'll go into some code demonstrations about how all the pieces fit together when we're talking about building one of these applications. So as a review, let's look at vector databases for a second. So these three here on the left are three different kinds of databases. I didn't put tabular databases on this because most folks are going to be familiar with that concept, but these three are different kinds of databases as well, where you have a key value database, and this is like Redis or Azure Table Store, where you have the ability to have a key and then you're able to retrieve data based on that key. You might have a document database, and the document database allows you to store hierarchical data in a document like a JSON document or XML, and then you store that in the database and you're able to get data out of that by selecting against those documents using some kind of language like SQL. And then you might have a graph database, and this is where you have different nodes, and they're related to other nodes by way of an edge. And you can have any different relationship with different nodes in this database. And so you basically have a graph traversal language that you use to query a graph using that language. So Neo4j has a gremlin, for instance, that allows you to kind of traverse the graph using the selection language that it provides. Now, a vector database is another kind of database that allows us to do what we call similarity searches or vector searches based on something that we're storing representing the data within a data point. And so what we do here is we try to encapsulate some kind of idea or some kind of meaning within a vector, which is basically just a point in multidimensional space. And so when I say something like cat or dog or squirrel, if I'm grouping those based on maybe common attributes, that would be a category or class. That would be similar ideas that would show up in this database close together. So these would be where I'd put my mammals, for instance. If I was classifying bananas, apples, or oranges, I might have a grouping that looks something like this. Now, you get the same thing for different kinds of birds and different kinds of reptiles as well. And then you might have something that's in between birds and reptiles, like a dinosaur, like a T-Rex. And so the concept of this multi-dimensional database store is that each one of these dimensions represents some kind of semantic data about that particular entity. And so whenever I take an idea and I vectorize it, it's going to store the data as that vector representation. So it's going to have 2 dimensions, 3 dimensions, or multiple dimensions, depending on how many dimensions I'm applying to whatever idea that I'm looking for. Vector databases will typically have hundreds of dimensions to try and represent everything that they're trying to work with. And this one is only using 3 for visual purposes, but you can kind of think about this concept and expand it into multi-dimensional space. If I was to query for something, if my vector landed me right here and I said, give me the 4 closest things to this point, I might get something that looks like this grouping right here with a squirrel, banana, apples, and oranges. Or if I landed something right here and I said, search within, I don't know, 10 units of this, it might give me a grouping that includes all of these down here. Or if I say, just give me the 2 closest, maybe it gives me these 2 right here. But it's using the similarities and the closeness related to this as represented by the vector to return the particular data that's stored in the vector database. And so the process of taking ideas and encapsulating them as vectors is where an LLM comes in. And that's what we're going to walk through next, is how do we go from something like text and go from that into a vector. So we've looked at a vector database. Let's look at the application architecture kind of around this. So there's 2 sides to this. There's the ingestion side and the application side. And we want to understand both of them because they have implications on how the entire system works. So we really start with some kind of source data, and this is typically text data in the case of a RAG app, but it doesn't have to be text data. It can be structured or semi-structured data, but typically we're looking at some kind of document repository. And that could be like a set of PDFs or Word documents or plain text data, whatever it might be. There's some kind of text and we want to be able to get some kind of meaning out of that. We want to search for meaning in that text. So we take that text and we send it over to some kind of ingestion algorithm. The ingestion algorithm will then take the source text and it needs to create a vector from it. And that is done by way of first doing what we call tokenizing it. And we'll see an example of that. But once we have it tokenized, then we take that and pass it off into an LLM that was trained on the same kind of text that is in our source documents. And the trained data will then be able to take the input from the ingestion and transform that into a vector of some kind that represents the semantic content. So is looking for similar context, similar meaning, related ideas, and then it's going to pack that into the vector that represents that, and then it's going to send that back to the ingestion algorithm. Then the ingestion algorithm is then going to store that vector inside the vector database as an embedding. And an embedding is typically what it's called. And so you'll have the embedding, and then alongside that embedding, you're going to have some kind of metadata. Now, the metadata could be the source data itself. You could take the actual raw text and store that in the vector database, which has been done before, or you could store some kind of key that will allow us to key it back to the original data, which might be stored in a separate data system. In any case, you're going to have some kind of associated data with it, because that will become important when we talk about the RAG app itself, because it's hard to go back from a vector to the original. But as long as we have a way to find the original data that produced that vector, then we'll be able to work with it. And it's actually going to be a lot faster too if we do it that way. So now that we kind of understand the ingestion side of this, let's talk about the actual apps themselves. So we're going to have the client app, and the client app could be mobile, it could be web, it could be something that you put on Alexa, whatever it might be. But you have a client app, and then the user is going to be interacting with that client app using some kind of interface. It could be just a text box and you're typing, or you're talking to the app, or whatever it might be. And you're producing some kind of query or command. And that is going to provide context. And the more context you can provide it, the better the results are going to be. Because if it's vague, it's not going to be able to match it closely. But if it's got a lot of good context associated with it, it's going to be able to understand the intent better, and you're going to get better results from the search. So that's what we're doing in the client app. We're just doing natural language to ask something, and we're trying to provide it as much detail as we can so that we get good results back in our query. So it's going to take that particular context then and pass it back to the API. And it's going to do something very similar to it whenever we're ingesting the documents. It's going to go to the same embedding model. That's important that you use the same embedding model to get the vector. Because if you use a different model, you're going to get a different vector and the results will be way off. But if you use the same model that you use to ingest the data as you use to vectorize the actual query, then you're going to get from that something that is going to be very similarly matched because it has a similar context. And then it's going to pass that vector back to the API. Then the API then is going to then call the database using a vector search. And the vector search is then going to find the closest matches to it, and then it's going to return those back to the API. Now, so far, everything that we talked about right here has been very similar to just a plain vector search. Now, what makes a RAG app a little bit different from just a pure vector search, though, is that it takes the results from the vector database and it does another step with it. It uses that to actually answer a question or perform some kind of action. So in this case right here, if I was wanting to ask a question from this API, I asked it to find me candidates that have these qualifications, and I want them to have the ability to perform certain kinds of actions, and I list those actions out. It's going to search for a candidate that kind of matches that, but then it's going to provide me with some kind of analysis of the actual source data that I originally looked at. And that's where it's going to use that metadata that we also stored to either retrieve the original data, or it's going to just use what was ever stored in the vector database. And it's going to pass that off to some kind of generative model. And it's going to provide it with the original context, and it's going to provide it with the query. And then the generative model is then going to analyze that data based on the original query, and then return a result. And that's where it's going to attempt to generate something for the user, such as answer a question based on that data, and then that ultimately gets returned back to the client application. So this whole process of a RAG app involves a lot of moving parts, but once you kind of get it all working, it gives you a very intuitive application interface that makes your application a lot more usable from the user's perspective, because now they're able to interact with it using just some kind of natural query language. But it also gives you the ability to have kind of a dynamic data source without having to rebuild models or do any kind of fine tuning. Rather, you're just using the vector search and then additional step to work with the original data to answer questions and then produce some kind of result that then gets sent back to the client application. So let's look at an example of this that I've kind of put together that kind of shows you the full scope of what's going on this particular slide right here. So the data that I'm going to be using for my demo is pretty straightforward. I'm going to be looking at resumes, which are documents, and I want to be able to search documents. So I have a set of sample data that I got off of Kaggle, which is a website that has a lot of different data sets on it. And this one has a set of resumes, and I just basically want to ingest these resumes into a vector database. And the fields that this has associated with it are the ID, which is correlates to a file name. I have the actual just string data, then it's got HTML data from the data itself, and then it's got a category, which would be something like HR or engineering, whatever it might be. So I'm mostly interested in the resume string right here, because that's what I'm actually going to be using for my embeddings as well as my searches. So let's take a look at the way that I ingested this data. And the code for this is pretty straightforward. I'm not going to go over this in minutia, but what this allows me to do is to have a set of data that I'm going to be using BERT with. Now, BERT is an LLM that allows me to run it locally, so I can run this on my GPU, and it's small enough that I can use it for embedding, but it's also large enough to where it'll understand the context of resumes. So I'm going to be using this to create the embeddings, and then the tokenizer is what converts the text into tokens, which is then passed into the LLM to get back the actual embedding that we're going to be put in there. And so this is the get embedding algorithm. It's just takes in some text, and then it basically vectorizes it and then returns the results back to me as an array. And this right here is just setting up the schema for the databases. I'm storing the embedding. I'm storing the resume, the category, and the actual string data that's in that CSV file that we just saw. And then the way that I got this wired up is I got it being done by batches of 100, so that I'm just inserting 100 records at a time into the database from that CSV file that we just looked at. And so first thing it does is grabs the text, then it gets the embedding. It did right here. And then it takes build a data set, basically a list of lists, and then inserts that into Milvis, which is the vector database. And then from there, it indexes using a cosine for similarity searching. And it tells it to create the params for that. And then down here, it creates the index on the field, the embedding field, which is the one I'm interested in. And then it's done. So it's fairly straightforward in terms of ingesting. So grabbing data, vectorizing it, storing it in the database, and then creating an index on that. And then that's how I get the results I want to search on. So let's go and look at the API for this, which is pretty similar to this. And then the way this is working is I have kind of a wrapper around this particular API. This is just kind of a request receiver that processes the request using RAG. So for I'm using the same tokenizer and the same model that I use to build the embeddings with. And this is then searching the database that I created when I ingested the data. And this has got the same embedding algorithm. Now, this one is slightly different in that the way that it actually performs some of the functionality on the data that retrieves from the vector databases. So all that's pretty much the same. So the query here is grabbing something from a from the data that's passed in from the request. This is a request object in Flask and in Python. It's getting a query. That's the actual question that's being asked. And then it's getting the embedding for that query right here, just like we did for the ingestion side. And then it's setting up some search parameters, and then it's actually running the search. So I'm basically saying, grab me the 5 closest matches for this particular vector that I created from the input. And then it's returning the embedding, the ID, the category, and the actual string. And then it's doing something with that data. It's taking the original query that I asked, and then it's getting an answer from the question that's in the query. So it's using, off of this particular API, I'm using Azure's ChatGPT 3.5 to take the search results and answer a question based on whatever is in the original query. So doing some prompt engineering here. So that's why I skipped over this answer question right here a minute ago. So this is actually taking the question and then the resume text, and then I'm giving it 2 roles. And this is pretty typical of some kind of just typical asking of a question for ChatGPT. I tell it, for my system role, your search assistant, the user will submit a resume, use that resume to answer this question. Then I give it the question that was passed in, and then the user context is just the resume itself. And then sends that off to ChatGPT. ChatGPT then returns some results, and then that's the answer, and then returns the answer. And then that's what gets put back on the result set. And then down here, rather, the result set that gets then passed back to the calling application. So again, a very straightforward implementation, but this is just how the code looks. And I did that on 100 lines of code or so. So again, it doesn't take a lot of code to create one of these, but once you have it all working, it can actually do some cool stuff. So let's go see this thing in action. I've started this application right here. This is my application that's written in Python. I started this in one tab in WSL, and this is Milvus also running in WSL. So Milvus and the app can talk over localhost, but this is WSL, so I need to expose it on this endpoint right here, which I've already pulled up in a browser. And so that's why we see that URL as just an IP and a port, because it's talking to that Flask app. And so this is just HTML JavaScript app right here, nothing special there. But this is where I can input the question that I want to ask it. So it's going to perform all of that we just looked at behind the scenes if I just ask it a question. So I would like candidates that have management skills, but can also code in C#, Python, and JavaScript. And so I'm going to be looking for resumes that have these kind of keywords, but this is kind of context right here, but it doesn't list any particular management skills. So let's see what happens if I click submit. And I can kind of see what's going on behind the scenes right here. It's going to get resumes and it's going to return those back to me. It's summarizing them right now using the LLM on Azure, and I got the results back already. And this is the result it gave me. So this is the question. So keep this in mind whenever we're looking at the summary right here. So this resume, so based on the provided resume, I would recommend considering the candidate where their management skills are C#. Although the resume primarily focuses on the web development, it does showcase relevant experience working as part of a team, highlighting the ability to smaller parts fit together, and so on. And this one, based on the provider resume, this one's saying I submitted multiple candidates, but I just submitted one resume. They have C# and a number of other skills, and they're mentoring junior developers, which would be management stuff. This one is talking about lead Drupal, overseeing in YSCD, which I'm not sure what that means. Experience guiding webinar webmasters and coordinating activities. So management skills there. And this one lists some hard skills right here in terms of development, JavaScript, Delphi, VB, but it also has troubleshooting and other things similar to that. It doesn't have a lot of management skills listed, but maybe it does include managing departments. Okay, that's good to know. And this one is a similar. So it's able to take the resume and kind of deduce from that, okay, is this person have management skills, and do they have the kind of the hard skills? And so this did provide me summaries based on resumes. And if I went to pull those up, I could look at the actual resumes themselves. And the sources for those are part of this directory here. If I go into the directory, into my data folder, I have all these resumes as part of the data set. And let's just look at this one right here. So under the construction folder, I have resume, this ID right here. If I search this folder, I should be able to get the source resume. And let's see what this has. And it's just listing a development skills, how a 15-year veteran in the construction industry looking for building a new career in web development. We're passionate about making these things a reality, and highlighting some hard skills and relevant experience related to and build like some different kinds of things that you would do in construction. That might be relevant to management as well. So interesting right there. So it's got some project management skills and coursework and those kinds of things. So after reviewing this one, I would think this one might be a more junior developer, but wouldn't be one that I'd be kind of looking for. But the LLM did highlight this one as having some management skills in any case. But you would have to go back and review these with the human eye, but you kind of see where the LLM was able to kind of summarize what I gave it, but it was also to match it based on the actual context that I passed in with this particular question right here. So just the ability to do that and search on these kinds of things is kind of one of those things that the RAG app will enrich an application experience based on whatever it is that you're trying to build. But this is kind of a canonical use case in any case. So this is the demo, but I will probably be working with this in future videos where I kind of look at other angles on this as well, because this is an interesting topic to me. AI in general has been, but this one in particular with building these style of applications and different ways that you can integrate it into different kinds of ecosystems. So thanks for watching, and I hope you've enjoyed this video. I hope it's been informative. If you have a question, drop in the comment section down below, like and subscribe to the channel. And as always, thanks for watching.
If you like this content, please consider subscribing to the channel by clicking on the subscribe button. You can also like this content by clicking on the thumbs up or share this content with your friends, and also comment in the comment section down below. You can also find me online at www.blaze.net or on Twitter at @TheOneMule. And as always, thanks for watching.